Hi, my name is Morgan, and I'm presenting a project that I've been working on at UC Santa Barbara. Using ubiquitous technology, I found a way to help rural users access and disseminate online social networking content beyond the borders of internet coverage. While the system has not yet been deployed, I will be presenting both the system design and the feasibility studies I've conducted that help show the potential impact that my project has on rural communities that exist beyond both internet and cellular coverage. This project was largely inspired by the digital divide in the United States, where less than 10% of Native Americans living on reservations have access to the internet. On reservations, FM radio has become an information lifeline, and people depend on radio programming for critical emergency announcements, health notifications, local news, and culturally oriented content. Taking a closer look at FM technology, it is easy to see why it works so well in rural areas with limited infrastructure. It has propagation properties that enable its broadcasts to be received up to 100 miles from the transmission site. This is why FM radio is still accessible even in areas where internet and cellular coverage are not available. FM technology also has a data subcarrier called the Radio Broadcast Data System, or RBDS, which enables small amounts of station information, such as the call sign or current song title, to be embedded into the audio broadcast. This data is also carried along with the audio transmission. While FM radio is excellent for distributing content over long distances, it is not supportive of interactive, media-rich content that is pervasive on the web today. In particular, it does not support the social networking experience, which enables asynchronous media-based collaboration. Online social networks have shown to be valuable tools for developing cultural resilience and identity. Both survey and observational studies reveal that online social networks are some of the most accessed sites on reservations when internet is available. In particular, online social networks provide an irreplaceable framework for marginalized groups to preserve language, organize around common goals, and engage with activism efforts. This led me to ask, what if we replace the station text of RBDS transmissions with online social network content? Could this allow users living beyond the borders of internet connectivity to receive social media even when they're offline? This image diagrams the high-level concept of broadcasting online social network content over RBDS. Instead of broadcasting directly to user devices, which do not always have activated FM chipsets, my design incorporates a content receiver box that receives transmissions and propagates them to user devices over a local Wi-Fi network. Users' annotations and uploads made offline are stored on their device until they reach a hotspot, and all their social media is uploaded to the internet. In order to evaluate the feasibility of such a system, I would need to answer the following. Can low bandwidth RBDS provide fair and adequate coverage to a high volume of social media content? To answer this question, I used Instagram posts representing all public posts received by 254 users from a previously studied network that connects 13 reservations in San Diego County. Over a period of 6 months, these users would receive 1.1 million Instagram posts. I then developed software that could simulate Instagram low data rate broadcast over the 6-month period using 5 different scheduling approaches. Despite the fact that RBDS broadcasts at only 1.2 kilobits per second, I was able to create a scheduling approach for broadcasting content that combined a scheduling algorithm with a model of social media propagation. I found that the best approach combines a round-robin scheduling algorithm with the media propagation model that maximizes the number of unique users who will be interested in a given piece of content. While some content is dropped and never scheduled, this approach ensures that content most relevant to a co-located community of users is selected for broadcast. I evaluated the approaches based on coverage per user, or the percentage of expected media each user receives, and fairness, or how evenly bandwidth is distributed among all users. The results were promising. Over 1/3 of the overall content was scheduled for broadcast, and the fairest scheduling approach is capable of disseminating social network content so that 81% of users receive at least half their content over a 6-month period. Through the development and implementation of this system, users who have historically been excluded from the unique collaboration opportunities afforded by online social networks can participate using infrastructure and technologies that are already widely deployed and affordable. As I conclude, I would like to highlight that software used to simulate Instagram broadcasts is publicly available at GitHub. Additionally, significant detail about the design and feasibility evaluation can be found in the publication that accompanies this project.